Good morning, everyone. So, here I am once again with another problem statement, and we are going to solve this using Raptor. So, the problem statement is write a flowchart to print all possible pairs of prime numbers such that the sum of each pair of primes add up to a user defined number. And this is an example. Say, for example, the user defined number is 10. Then all possible pairs of prime numbers that add up to 10 are 3 and 7 and 5 and 5. So 3 and 7 are prime numbers and 3 plus 7 is 10. 5 and 5 both are the same number. Both 5 is a prime number, and if you add 5 and 5, we get 10. So the user defined number could be anything. And we have to find out or print all possible pairs such that the sum of the primes is equal to uh, number the number that the user defined. All right, so let's go to Raptor and let's try to look at what possibly can we do. Now this problem typically has uh, more than two solutions. Prominently, if you think, it has got a naive solution, a solution uh, which immediately comes to mind is maybe what I would do is uh, create an array of all prime numbers that are lesser than the given number, and then check uh, by uh, looping through that array, check if there are two elements within that array which add up to the given number. So we'll have to probably create firstly an array of primes lesser than the number and then do the check. For doing the check, obviously, uh, we'll have to run a loop within a loop. And in terms of time complexity, this solution would be then n square. Now, I will in my subsequent lectures be giving you a tutorial on algorithms, time complexity, data structures. So, we will be following a logical, progressive way in which all these lectures would be arranged in the future. But there was a popular demand for the solution for this problem, and therefore here I am with what could be an optimal solution. All right, so let's begin, and let's start with a number because that's what we want in the beginning. So we ask or prompt the user to enter a number, and then we store it in a variable called n. Cool. So we've got a number, we've stored it in a variable n, and this is going to be a lengthy tutorial because we will have to use something called a function which we have not used till now. We will have to create a function for checking if a given input is prime or not. And we'll get to that. And I'll show you how to create functions using Raptor. Uh, so yeah, so we've got an user input, we've got a number, we've stored it in a variable called n. And the next thing that I want to do is I want to run a loop. My loop should begin with 1. It should begin with 1. And it should iterate uh, progressively by 1. So beginning from 1, 2, 3, 4, and so on, I want my loop to terminate as soon as my I becomes greater than n. So my um loop will iterate n times, n being the number that the user enters. So let's go ahead and do that. But before we do that, because we are using Raptor to solve this, I'll have to take a variable. Let me call that variable I, and I will set it to 1. So if you are from other programming backgrounds, usually, for instance, in Java or C, you would be iterating or beginning your iteration from 0. So the initial value or the initialization is 0 usually. In Raptor, we typically start with 1. All right. So once I have that I'll take a loop and I'll give the condition which I just defined. I should be greater than n. As soon as it happens, then I want to exit the loop. So the program doesn't enter the loop again, it will exit. All right, cool. So I've got that part done and I want to progress through all values of I. So I is I plus 1. I am iterating through 1, 2, 3, 4, 5, 6, and so on till I reaches n. All right. Now I want to check whether my I is a prime or not. And to do that, I am not going to write the logic here. What I will do is I will create a new function, and the way to do that in Raptor is to right click on the main tab, click on add procedure, and you have a dialog box that opens up. So here you define the name of the procedure. So let me call my procedure check prime because I want to check whether a given or entered number is prime or not. It will take a parameter say num as an input. So I have checked my input checkbox as the num parameter. I also need an output, and my output is not going to be a value, it is rather going to be a boolean because I want to check whether the entered number is prime or not. So I want an answer like 0 or 1, true or false. So the output has to be true, false, or 0, 1, 0 being true, 1 being false, or vice versa. So it has to be Boolean in nature with either or as an output. So in that case, I will click on output as my parameter number 2. I will uncheck the input box because I don't want it as an input. It has to be an output. And I will name it as flag because I am going to flag or give some value to this flag. So flag would be either 0 in case it is not a prime and it will be 1 in case it will be a prime. So that's the logic I will be using. All right, cool. So I have my check prime function ready. So as soon as I define my function and give the various parameters, Raptor will create the function for you. And now I can start defining what my function does. So my function in the beginning will set the value of flag to 0. And remember, I mentioned that 0. Oh, I'm sorry. So I'll comment here. So 0 means that num is not prime. All right. So 0 means that my number is not prime. So I am starting with an assumption. I'm starting with the assumption that the value of num, whatever it is not prime. It's not a prime number. And then I am doing something more interesting. So I will, if my value, if my num, if my input is either 1 or 2 or 3, then I will be assuming that they are prime. So I will say that if the input number is 1, or if it is 2, or if it is 3, then I'll say that the flag will be 1, 1 being that it is prime. All right. So the way I will express this in Raptor is using a if else selection symbol, the one that I selected, and then in the rhombus or the diamond shaped bracket, I will write num equals 1. And either use the pipe symbol for or I can directly write or. Oh, sorry, or. So I'll use the pipe symbol for now. Num is equal to 2 or num equals 3. If yes, so if the num is either 1 or 2 or 3, I will simply set the value of my flag to 1. So I'll say flag is 1. I need not do anything further. And here I will also mention that 1 means that num is prime. So 1 means that, yeah, I'll put it here, means that num is prime. Cool. So now, once we have got 1, 2, and 3 out of the way, and I have put the right condition for my flag, I will have to check for the rest of the values of num. So num could be anything. Remember, what I am going to use this function for is to check for each I whether it is prime or not. So I want to check for each value of I whether it is prime or not, and therefore I am defining a function check prime which will take this I which begins from 1 and which ends till n. I want to check for each value of I whether it is prime or not. So this is the definition that I will follow. All right. So flag is 1. Cool. So what I am going to do now next is I will take a loop, and here in this check prime function, the input is num. So when we are defining something, I'll be taking the value num or the variable num and doing some operations on it. All right. And before I even start doing anything here, I will take one variable called k, and I will set the value of k to 2. I want to check whether k is able to divide num wholly or not. By wholly, I mean whether num divided by k doesn't leave a remainder. So the remainder should be 0. So if I divide num by k, the remainder should be 0. So I will do and check that. And till when should I run this loop? I have to run this loop till my k becomes greater than num or num by. And if you have a little problem understanding why am I running the k till num by 2, please check my previous lecture, uh, which where I have explained how to check whether a given number is prime or not. But those of you who are new, just let me. So I will check for all values of num till I reach the halfway mark or till I reach the midpoint of num. So beginning from 2 till k becomes greater than num by 2, I will check, because beyond that it doesn't make sense. It's going to be a fraction anyway. For example, if my num is 10, Then num by 2 will be 5. And if I start checking, I will just have to check whether 10 is divisible by 2, 10 is divisible by 3, 10 is divisible by 4, or 10 is divisible by 5. That's all I need to check. I need not have to check whether 10 is divisible by 6 or not, because it doesn't make sense. It's going to be a fraction anyways. All right. So that is why I will not go beyond num by 2, halfway, half of the value of num, because beyond that, if even if uh, I assign a value to k and try to divide the number by that value of k, it is going to be a fraction. All right. So num by k. And now, if uh, if it is not met, this condition is not met, then I will use a selection box, and then I will check whether my num percentage k is equal to 0 or not. Remember, 0 means, I have defined it here, 0 means is not prime, 1 means it is prime. Now, if it is 0, we'll simply set the value of flag to 0, because if k is able to divide num, then the flag is 0 because it is a factor of num, and therefore num cannot be a prime. So if it is the case that num cannot be a prime, I need not continue this loop any further. So I will create a condition where I exit the loop automatically, and for doing that I will assign my k with the value of num. Num being greater than num by 2, this condition would be fulfilled, and the loop exits. However, if num percentage k equal to 0 is a no, then I will say my flag is 1, and I will check for the next value of k, which is k plus 1. K is k plus 1. Now I have this function ready. Cool. And for a number to be prime, it cannot be divisible by any value of k. So k can be 2, 3, 4, 5. Every time the flag has to be 1. If it is divisible by any number and flag becomes 0, I exit the loop and flag remains 0. So the logic is that in this case, 1, if 1 is returned by this function, then the value of I, which I will input as the input parameter, is a prime. If it is 0, it is not a prime. And that is exactly what I'm going to do here. I will call this function check prime. I will give I as the input, because I is my iterator here for this loop, and I will store the return value in a variable called f. Remember, f is either a 0 or a 1. 0 means not prime, 1 means prime. And now I will use selection. Now see, if I get a value I, which is prime, then I have to do something. And let's see what will I have to do. So if my f is 1, which means that the input number I is a prime number, if this is the case, I will use another selection. Now before that, I want to use this function. Now remember, this is the crucial part, and this is the part which most people miss. I will now check whether this function, and instead of I will just check if my input number n minus I is also a prime. Oh, sorry, not 1 I, is also prime or not. So in my case, if I give you an example of 10, so one of the pair that we found was 3 and 7. So going by the chronology here, if my I is 3 and I find that 3 is a prime, all I have to check is whether n minus 3, which is 7, is a prime or not. If that condition is also met, then my pair is 3 and 7. I found my pair. That's it. So I will use this function again to check whether n minus I is a prime or not. If I is a prime and n minus I is also a prime, in that case, if this is also a yes, and I will use a selection here again, if both are, so this is yes, and again this is yes. So here also, if f is equal to 1, then I will say output pair found, and the pair will be I plus, let's give it a comma here, plus, give a space, and plus n minus I. This is going to be my pair. That's it. This is the logic for finding all possible pairs that give a number, a possible pairs of prime. If I want to run it, let me put a number like 10. Okay, there is an error. And I think this is the error because n minus I is not been recognized. So what I will do in that case is, let me just use an assignment here, and let me say, let me take another variable m, which is n minus I, and I will put m here, and now I can say m here. Now I can run this. Set 10, 3 7 5 5 and 7 3. So this pair is, so the answer is correct. So this is how you will find all pairs which add up to a prime. So I hope you found the explanation interesting. And I know there are a few things that I could have done better or explained better, but I will keep improving the quality of my videos, that is for sure. So keep following, keep watching. I am going to cover all the data structures and algorithms using flowcharts, flowcharts, Raptor, and then we will graduate on to a programming language like maybe Java, or we could use Python also. So I will be giving you a thorough explanation in my subsequent lectures. So till then, I hope this video makes sense for you. Try practicing what I have done here, and hope to see you in the next video. All right, thanks. Goodbye, everyone.